Welcome back to Just Academy Mathematics, where we make you a mathematics genius. This is a sequel. In our last class, I talked about example 1 to example 6. You can see this is example 7. So if you have not watched the last class, please make sure you watch the last class so that you'll be able to get a better understanding of this. Now, I'm going to be treating about 6 more examples here, or 7. And we are looking at factorization of algebraic expression whose degree is greater than 2, that is beyond quadratic. We are looking at factorization of cubic expression, quartic expression, and so on. If you look at this now, this is a quartic expression raised to the power of 4. You get what I'm saying? So this is not a quadratic expression. If it's a quadratic expression, the highest power will be 2. So we are concentrating on factorizing expression that the power is greater than 2. Power 3, power 4, power 5, power 6, and so on. So now it's a continuation. Let's just continue without further ado. Now, if you look at this question now carefully, like I said, algebra, when it comes to factorization of algebraic expressions, you just need to be versatile. Sometimes you can't say that this must be the way you will do it. It is the question that determines what you do. The question is like this, the next question may not be like this. So it is the question that determines the ideas that will flow through your mind and that will determine what you will do. So if you look at this question now, it will not be easy, even if it's even possible, to just go ahead and factorize it direct the way you do quadratic, because this is not quadratic. So the principles of quadratic may not be applicable here. Now, but we can do something. If you look at it carefully, very carefully, you will notice that apart from this 4s raised to the power of 4, from here down to this place is a quadratic expression. So what I'm going to do now is let me isolate this quadratic expression and factorize it separately. So this is what I mean. So this is 4x raised to the power of 4. If I bring this minus here outside, what will remain here will be what? X squared plus 12x plus 36. Does that make sense? So I just brought out the minus, factor out the minus outside, and this is what we'll have. So it's becoming clearer now that, of course, this is a quadratic equation, right? We can go ahead and factorize this. We know how to factorize quadratic equation. So we'll look for two numbers we'll add to give us 12, and when we times it will give us 36. And of course, that should be 6 and 6. So we'll come here and step this down again. 4s raised to the power of 4. Then we have x squared plus 6x plus 6x plus 36. Of course, from there, we factor out the common value there. When we factor out the common value there, x is common. What will remain? It will remain s plus 6. And of course, what is common in these two pair? 6 is common. What will remain? It will remain s plus 6, obviously. So we have that 4x raised to the power of 4 minus, if you take one of these, you are going to get s plus 6. Then times in what is remaining, s plus 6. So in other words, we are saying that 4s raised to the power of what? 4 minus s plus 6 raised to the power of what? 2. So notice that this one now is square. It's a perfect square. This expression is a perfect square here. And this one can be expressed as a perfect square. How? This can be expressed as 2s squared raised to the power of 2 minus x plus 6 square. So if you notice, since this is square and this is square, then we can treat this as a difference of 2 square, which I have treated before. If you don't know it, you can go and watch it. This means this. This is this. Applying difference of 2 square here, we are going to get that 2x squared minus x plus 6. That is the first one. And then we'll get that 2x squared plus x plus 6. That is by difference of 2 square. So let's open up. We have that 2x squared minus x minus 6. Then here we'll have that what? 2s squared plus s plus 6. We can stop here if any of this cannot be factorized. But if any of this can be factorized, we are still required to factorize it further. So if you check this one now, add to give you minus 1 and times to give you 12. Add to give you minus 1 and times to give you minus 12. I think minus 4 plus 3 will work here. So this can be factorized. Minus 4 plus 3 is minus 1. Minus 4 times 3 is minus 12. So this can be factorized. But for this, add to give you 1 times to give you 12. Add to give you 1 times to give you 12. I don't think this can be factorized. There is nothing like that. Add to give you 1 times to give you plus 12. Plus 12. There is nothing like that. So this cannot be factorized. So we'll go ahead and factorize this as 2s squared. Of course, this is minus 4s plus 3x minus 6. That is still this bracket. Followed by 2s squared plus s plus 6. Can you see now? So what that means is that what is common here? 2s is outside. What will remain? X minus what? Minus 2. And what is common here? Plus 3. What will remain? S minus 2. Then we step this down. Then finally, we can state that, this one will come out. If this one comes out, that is x minus 2. What will remain here? It will remain 2s plus 3. Then times in what? 2s squared plus s plus 6. This is the factorization of this. So you can see it's different layers. One step, one step, one step to another, one step, another step, and so on. Okay, so you can watch this over and over again for better understanding. Let's move on. Look at example 8. Look at example 8. Look at example 8. Raised to the power of 6. That is why I said we're looking at factorization of algebraic expression whose exponent is greater than 2. That is, exponent is greater than 2. Now, this is raised to the power of 6. What do we do with this kind of expression? Let's see. Remember the algebraic identities. But first, we can step this down as this a raised to the power of 6. We can write it as a raised to the power of... Okay, let me just step it down first. B raised to the power of 6. We can rewrite this as a raised to the power of 3. Or, okay, any of them will work, but let me work with a raised to the power of 2 raised to the power of... Any of them you follow will work anyway. If you say a raised to the power of 2, then raised to the power of 3, that is cool. That will work. And if you say a raised to the power of 3 raised to the power of 2, that will still work. This is what I mean. Square minus b raised to the power of 3 square. Another person can decide to use 2 here, 3 here, 2 here, 3 here. It's still the same thing, but it's different application. This one is difference of 2 square, but the other one, you have to apply the identity for raised to the power of 3. So for this now, we can apply difference of 2 square here. And when we apply difference of 2 square here, we're going to get a raised to the power of 3 minus b raised to the power of 3 times n a raised to the power of 3 plus b raised to the power of 3. So we are now to apply this identity. There is an identity that represents this, which states that a minus b times a square plus ab plus b square. That is the identity. This is this. Then the identity for this one with plus is a plus b times a square minus ab plus b square. Can you see that now? So this is the breakdown. So if we write this as a minus b, then a plus b followed by a square plus ab plus b square bracket a square minus ab plus b square. Let's check if any of this can be factorized. Add to give you 1 times to give you 1. There is nothing like that. Add to give you minus 1 times to give you 1. How about add to give you minus 1 times to give you 1? There is still nothing like that. Minus 1, 1. Add to give you minus 1 times to give you 1. There is nothing like that. There is nothing like that. Add to give you minus 1 plus 1 times to give you 1. No way. Assuming it's 2, we will say minus 2 plus 1. So, since nothing can be factorized here, we can as well leave it like this. This is the answer. That is the solution. Because you cannot factorize it further. You just stop there. Okay, that brings us to number 9. You can see number 9. So for this number 9, this is quite technical. Why do I say so? If you look at this number 9 carefully, you will notice that this is actually difference of 2 square. And this is difference of 2 square. But if I expand this one and expand this one, it will not make sense in factorizing it. There is no way I can relate it with this. So the next thing is to open this bracket. Let's expand this. So in expanding this, I will get that a square will times b square minus 1. And I will get that minus 1 will times b square minus 1 plus 4ab. So let's open up. We'll have that what? A square b square minus a square, then what? Minus b square, then what? Plus 1, then what? Plus 4ab. So the next question now is, how do we group this? I told you before that when you see a square, b square, you see ab, know that they will go together, but not in all cases. For instance, in this case, it will not work because there is nothing you will add to give you 4 and times to give you 1. It can only work for 2. There is a number you will add to give, for example, 1 plus 1 can give you 2, and 1 times 1 can give you 1. So assuming here is 2, then we can merge this with this. So we can merge this with this as it is now. And this cannot go with this because this is positive. I will have said this and this will go together to give us a perfect square. So what do we do? The next available option is to split this one into 2. This is what I mean. We have a square b square minus a square minus b square plus 1 plus 2ab plus 2ab. Because with this, we can be able to merge this now. Watch this. We merge this, this, and this. This is what I mean. A square, b square, pick one of this, plus 2ab, plus 1. This is one of the group. Then in the other group, for you to see what happened in the other group, because in the other group, first we have minus a square plus 2ab minus b square. I'm just showing you so that you speak. I want to bring out a minus. I'll step this down again. ab square plus 2ab plus 1. Then here, minus 1 is outside, or minus is outside. If minus is outside, what will remain here? What will remain here will be what? A square minus 2ab plus b square. So we can factorize both of these. They are factorizable. So for this, 2 numbers you will add to give you 2 times to give you 1 is 1. 1 plus 1 is 2. 1 times 1 is 1. So this one can be split as a square b square plus ab plus ab plus 1 minus this one. Add to give you 2 times to give you plus 1 minus 1 minus 1. A square minus ab minus ab plus b square. For here, what is common? AB. AB is outside. What will remain? AB plus 1. Here, what is common? 1. 1 is outside. What will remain? AB plus 1. So that is for this. Minus this one, what is common? A is outside. What will remain? It will remain A minus B. This one, what is common? Minus B is outside. What will remain? It will remain A minus B. And this. Are you following now? So we pick the common bracket A plus B, AB plus 1. What will remain here? AB plus 1. Then minus, for this, we pick A minus B. What will remain? A minus B. Are you following now? So that is what we are seeing now. Then so at this stage, there is nothing that can come out because none of them have anything in common. But this is perfect square. We can put this as a square. We can put this as a square. But we'll rather list it like this. I get what I'm saying. It's not difference of 2 square. Okay, difference of 2 square is applicable. Wow. So this is A plus B plus 1 square minus A minus B square. So we can apply difference of 2 square. Remember, difference of 2 square. So this is A plus B plus 1 minus A minus B. That is the first possibility. And A plus B plus 1 plus A minus B. So we open up to get our answer. We get A plus B plus 1, AB plus 1 minus A minus B times AB plus 1. Sorry, minus times minus is plus here. Plus A minus B. So finally, we can arrange it as AB minus A plus B plus 1. Then AB plus A minus B plus 1. This is the answer. Interesting, is it not? So you watch it over and over again to understand. That is example 9. So there is no one way. You can't say that this is how it must be done. No, it depends on the question. Now look at this one. I have 2 more to show you. Look at this example 10. Just if you look at this example 10 carefully, you will notice that there is something common here. And I think we should start by, because even though everything here can raise to the power of 4, but everything here cannot raise to the power of anything, so the first thing we have to do, I think is better for us to do, is to factor out what is common here first. And what is common here first is 3 is common, and s raised to the power of 4 is common. So if I bring out 3 and bring out even y2 and bring out s raised to the power of 4 and bring out y, what will remain? What will remain? It will remain s raised to the power of what? 3. And what will remain here? It will remain 27. 3 times 27. Y raised to the power of 3. Can you see that? Because this time this will give you this. This time this will give you this. You are going back. So this is the same thing as this. Are you there? Now notice that everything here can go to power 3. So we can apply the cubic identity. So this is 3s raised to the power of 4y times s raised to the power of 3 minus 3y raised to the power of 3. So we can apply the cubic identity for power 3 there. Now we have 3s raised to the power of 4y times, this means x minus 3y times in s square plus 3xy plus 3y square. That is it. So this means 3x raised to the power of 4y brackets x minus 3y, of course, brackets this one means what? This one means s square plus 3sy plus 9y square. I think we may have to leave it like this. I don't know if there is any other thing we can factor in here. We should leave it like this. We should leave it like this. I don't know, but this is what I think we should do. Just, I can't really see any other thing here. 3xy plus 9y square. So these things can really be very tricky sometimes. It all depends on what you can see. We'll leave it like this. So let's conclude with this. Let's conclude with number 11. Look at number 11. Let's conclude with number 11. So for number 11, it's an interesting one. If you look at number 11, that is why I say there is nothing like it must be done this way. No, it all depends on what you have. If you look at this number 11, notice that s squared minus 3s is here, s squared minus 3s is here, regardless of the minus 1 here. So that is a pointer that there is something common first. In other words, I can write this as s squared minus 3s times s squared minus 3s minus 1. I'm repeating what is there, equals to 20. So what I am trying to say is that since s squared minus 3 is common, I can even say let s squared minus 3s be equals to p. In other words, anywhere I see s squared minus 3s, I can put p. So here will now be p brackets p minus 1 minus 20. Interesting, is it not? So this is p squared minus p minus 20. I had to give you 1 times to minus 1 times to give you minus 20. 5 and 4 will, yes, 5 and 4 will work well. Minus 5 plus 4 should work. Minus 5 plus 4 will work. So we have p squared minus 5p plus 4p minus 20. And what is common here? P is outside. What will remain? P minus 5. What is common here? Plus 4 is common. What will remain? P minus 5. Of course, factor out the common brackets. P minus 5. What will remain? P plus 4. So this is the factorization. Then we can now recall that what? That anywhere we see p, we are going to replace s squared minus 3x. So let's do that. So we have s squared minus 3s minus 5. Then s squared minus 3s plus 4. Interesting. Interesting, is it not? So it's better than raised to the power. Assuming it went to raised to the power of 4, assuming we open the bracket, we will have still been able to do something. And, there is always more than one way to approach it. Okay. So here we check, can this be factorized? Add to give us 3 times to give us 5. Anything like that? I don't think so. There's nothing like that. Factors of 5 are only 1 and 5. And that cannot give us 3. So this cannot be factorized. Factors of 4, 1 and 4 can work. 1, 4, 2. But 1 and 4. How about minus 4 plus 1? Minus 4 plus 1 can give us minus 3, but minus 4 times 1 cannot give us minus 4, since here is plus 4. So, in other words, we are simply saying that none of this can be factorized. If none of this can be factorized, then we'll have to leave the answer like this. So that is it. Thank you. Make sure you subscribe. You want one-on-one. You are interested in a one-on-one tutorial, contact me via the WhatsApp link showing. See our next video as we continue our series in quadratic equation. Thank you.